The mathematical models in physics are fantastic. They are verified very well, and in quantum theory with a high accuracy, and Einstein's prediction could all be observed. But we have a problem. We do not understand physics anymore. Why can a particle be at several locations at the same time? Or why can a particle be a wave and a particle? And why can a mass increase just by a transformation of coordinates? Well, we don't understand this no more. And we recognize that these models are only descriptions, but no explanations. And I would like to have explanation to understand physics. If you look at the Boltzmann equation, at the equation of the ideal gas, we see this is only a description. It is not explained why temperature is changed. And it was Ludwig Boltzmann who found it out. He thought about atoms at a time where nobody believed in atoms, and he did not get any acknowledgement. But I think we should anyway do something like the bigger scissors. We should try to find explanations for that. And there is a question, are these models, do they make a physical sense? And if you go back to the Middle Ages, where people believed that Earth is in the center of the universe, then there was the epicycle theory developed, and this was very ingenious. Somebody had the idea that planets orbit around the center, and the center orbits around the Earth. And so they could explain all the orbits of the planets and predict even orbits of planets which were not detected at the time. But we see that such a model is physical nonsense, but one can verify it. And then there's a question, is that possibly the same or similar to the space-time modeling? And I say yes. But I bet you will not accept my arguments. Because they are not scientific. Let's go back to the year let's say 1780, and imagine you would meet Luigi Galvani, who tells you about the dead frogs on his clothing line. And the dead frogs become alive when there is a thunderstorm. And he says, in the thunderstorm there must be a living elixir. How would you react with today's rules of physics? I think you have to reject this observation because one cannot repeat it. And I think we should also include observations which cannot be repeated. The rule that experiments have to be repeated into that came up in the late 60s. And it has a good reason. because at that time there lived a woman in Russia which could move small objects by her mind. Her name was Nina Kulakina. And you can read her documentation. Scientists were convinced that she can do it. She could develop a neutral force which is 10 to the power of 40 times stronger than normal gravitation. How can that be? If this is true, that's clear. A woman can do many things, but she cannot bend space-time so much. Gravitation must be something completely different. And here in Belgium, there was an event, maybe you have read it, in 89, beginning of 1990, where thousands of people saw a UFO, an object which could move from A to B without inertia in a part of a second, could move very fast and very slow without noise, and people who were familiar with technology knew it cannot be a technology from the Earth. And here we see that we are indoctrinated by Einstein's assertion that the light speed is the maximum speed that is possible. But is it true? Anyway, this was my motivation to think about mechanisms which could explain this phenomenon. And the question is, could one falsify the theories of relativity? About 20 years ago, a German physicist, Günther Winz, demonstrated that he can transmit a symphony of Mozart with an 8-fold speed of light. One could see it on the screen that the signals came earlier and they were not deformed in an early this order. But many scientists declined this observation and said this is not possible. But their interpretation was wrong. The secret of that is in tunneling in quantum theory, where it takes no time for us to go from one side to the other side. And some years later, a Russian team could demonstrate that for electrons, and some years ago, an Australian team. And then there is the other effect. At solar eclipse, I detected that the pendulum behaved very strange. Then in the next years, scientists did the same experiment, but they didn't find any other effect. But in the meanwhile, this effect is very reliable, detectable, and the scientists found out that it depends on the angle of the pendulum, of the oscillation plane to the axis Earth, Moon, Sun. So it can happen that one can nothing see. I'm trying to go another way. You remember Hermann Bondi? He demonstrated that all formulas of the special relativity can be expressed as a formula of the relativistic Doppler effect. It's called the K-calculus. The textbooks make it easier to come into the theory with that formula. But if you look at that, you see, if you have a little bit of idea of statistics, that this is a geometric mean of the classical Doppler effects. But if there is a classical Doppler effect, there must be a reference frame outside of the frames A and B which move in opposite directions together. So, is it possible that there is a frame, a special frame where light is propagating isotopically? By the way, if you are interested, you can read that in this publication, where I deduced the Lorentz transformation by 3 completely different ways, and always get a geometric mean. By the way, if one let's regard 2 inertial frames A and B which move together. If one looks from an upper frame, one could say the observer in A has the light speed c minus v or c plus v, and building the geometric mean from that, we get a mean speed of light. And if this includes in the Galilean transformation, we get the Lorentz transformation. So we have a funny situation. The Lorentz transformation says that each observer in the inertial frame has the velocity c. But regarding from up frame, one can say with the same formula of the Lorentz transformation that the common speed for this reference frame, for this inertial frames, is the mean value of c divided by r. Is it possible to prove that experimentally? It has been done by Gerald Wimmer, who tested the time duration with the Doppler effect. And he found out it's everything okay. It's the zero of special relative is valid, but with the same experiment he found that the line of the spectral line, the width of the spectral line was 10-fold wider than expected. Then he tried to explain it. He found many reasons, but finally he came to the conclusion that there must be a reference frame outside where light is propagating constant and isotopically. If you read the last sentence, you can see it. I suggested to do an experiment to complete the situation where 2 frames move together, and I assumed if there is a reference frame outside, then you have for the smaller, for the observer with a smaller velocity, and the observer with a higher velocity, different Doppler effect results. But if we regard the experimental result of heavily heating, and we assume that we get the right reference frame for the light is isotopical, then we find that here we get again a geometric mean, and here from the classical Doppler effect, and both the sender and the receiver are moving from the viewpoint of A and here from the viewpoint of B. And a little bit different. But we see that when the velocity of B is very small in comparison to A, we get exactly the same formula as the formula of the special relativity. So we cannot see any difference. The only possibility is to use the same velocities for A and B. Then you see up there, the gammas would be cancelled mathematically, and then we could compare two formula. But it is very difficult to get a difference because one needs very high speeds to find here a difference. And I hope that this experiment is done. Someone, and it will come out if the left formula is correct with reference from outside, or if the formula at the right side, which is the Einstein formula, if this is correct. Anyway, if the experiment would, if this is right, would confirm my point of view, theorists would apply the existing formula because we have no valid theory which can be used. And I'm glad that many people think about physical mechanisms to get a better idea. And finally, I suggest, just as a trial, some postulates to think about such things, and we should discuss that by the internet. I say each property is based on a structure. That means the electron, which has many, many properties, you could feel the pain of it, must have a very complex structure. To describe an electron with strange properties is far too simple. And then I have a similar idea like a predecessor. The elementary particle changes its structure all the time and very fast, so that one can measure only a stroboscope effect. And we have the impression that this superposition of quantum states. And third postulate, I reactivate the idea of Fazio the dA. He lived at the same time in Newton, and he discussed this idea with Newton as well, that gravity is based on pushing particles. This theory was declined, but why? because they applied macroscopic properties to this particle, and this is stupid. One should really invent completely new properties to apply that. If we take these three postulates or try out, then we see that an elementary particle is pushed forward, and if it changes the structure, it is pushed backward. So one can explain the double-slit experiment, the quantum eraser, the Heisenberg's uncertainty relation, and a lot of things more. But I did not create a theory. I think one person cannot do that. It needs the creativity of the whole world. And of course, all these postulates can be modified and exchanged and so on. And I also think that an elementary particle will tries to get in equilibrium with the environment. And this is the reason why there is inertia. It's forced to change the structures. Okay, that's all. I would like to thank all.
Thank you. Any questions? Please, any questions? We have not so much time. Please, one question. Please.
So, I have to check once more, but I guess that these two formulas are equivalent. I mean, mathematically they are equivalent and you can check it directly. So I'm not so sure. What do you mean?
Sorry, I didn't understand.
Okay, look. You have this question about the difference between two formulas, classical and Morpheus.
Yes.
So, and you say that they produce different results.
I hope so. I don't know. I hope so.
Okay,
Yes.
it's very easy to show that they produce the same result. You just have to make some simple mathematical transformation. I did it here, I can show you.
Okay, nice. Thank you very much.
Yeah.
Thank you. Let's thank our speaker. Thank you, Doctor.